Okay.
Okay, hi. Very quickly, my name is Bill Gartner, and I'm a teaching professor and senior research scientist here at UW-Madison. And I teach GIS applications, cartography, a bunch of other courses in the department. In any event, I teach a class called GIS Applications, which is pretty much a baptism by fire. Um, as all of you know, once you leave the university, nobody hands you a 50-page lab with a screenshot by screenshot set of instructions, and so basically, GIS applications is all about students figuring out problems on their own for oftentimes with just a few sentences. Hey, can you figure out a solution in GIS to this or that? So the major portion of the class is a final project, and Janelle and Jonathan and I were just talking about the projects one day, and there's just a whole bunch of great stories that are associated with them. So we thought it might be fun to do a lightning chat where students will take 5, 7, 8 minutes or so and present their capstone statement and some output, but then tell us a story of their trials, tribulations, and triumphs within a GIS environment. I don't think we tell these stories often enough. We tend to focus on our technical, our technical prowess, and definitely the students have lots of technical prowess, as you're going to see today. But the point is to engage in some storytelling, and please ask questions of the students when they're done with their little lightning chat. So with that, I'll turn it over to Ian and Will, who are going to talk about public transit access to hiking trails in San Francisco.
Hello, I'm Ian.
Hey, and I'm Will.
And yeah, we're going to talk about equity of public transit access to hiking trails in San Francisco. So some of our kind of inspiration or putting it in the general field is that there's the Transit the Trails Act, which has been introduced to Congress a couple of times with basically the goal of getting more underserved communities out to trail access just because there's so much great physical and mental health benefits. So we wanted to look at how transit access in San Francisco is to surrounding hiking trails, and does that access vary along socioeconomic lines?
All right, so here's a broad overview of our process. As Bill knows, our process is a whole lot more complicated than this schematic, but in the interest of time, we've definitely tried to distill it here. So we're using several different technologies here, primarily in QGIS, a little bit in ArcGIS, but also for our routing, which gets us from our census block groups, which are input data, to our trailheads for our suitable trails. That all occurs in the R5R routing engine. Yeah. So here's just some output or some inputs. So we have 2020 census block groups that we pull in. We derive centroids from those, and those serve as our input origins for each. So yeah, we're calculating from each input how access is approached from that. And then here's a picture of, so we take in trails. Through this process, we've taken in trails from 3 different sources. We did a whole bunch of work to query out trails that were paved. Also a lot of manual dealing with snapping issues and overlapping and all that kind of thing. And then the map on the right then is our final 5+ mile unpaved trail, which is our threshold that we decided we wanted to have a longer hike. So that's the 5+ mile and unpaved to get at kind of natural surface. And we made trailheads off of that, which then serve as the destination for that routing.
So basically, here's our number of accessible trails. We're actually pretty pleased that every block group in San Francisco can access at least 20 trails within a 2.5-hour transit ride, which was actually better than we expected. So we were pretty happy about that. And then we did kind of a weighted scoring so that we could find which block groups had access to quicker access to trails and how many rides it would take to get to those trails. So we created kind of a weighted trail accessibility score, which is actually really interesting to look at because this kind of the center purple line is the Bay Area Rapid Transit, and that seems to play a pretty huge part in how many trails are accessible and how accessible those trails are. And then getting to kind of comparing with our socioeconomic factors. Again, kind of the path of the BART is pretty evident, which we thought was very interesting. There's not really any relation between income vulnerability and your access to trails. Same thing we found with race vulnerability. So neither of those really had a strong correlation. And then finally, vehicle ownership did have a pretty strong, or did have somewhat of a correlation of R squared of 0.28. This one was especially interesting because a lot of that was clustered in this kind of northeastern area of San Francisco. So we were wondering if there's potentially more confounding variables, like people who live near to the BART and have better access around the Bay Area. Maybe they don't own a car because it's less of a necessity for them. So we thought that kind of stuff was very interesting from our study.
And a quick aside here is that originally we had wanted to build kind of a social vulnerability index, but really we found, especially only having 3 variables, it was really difficult to start to piece together, like, how do we have these things relate? How do we weight them against each other? And then also we ran a bunch of regressions and we really found no correlation between the variables. So then we ended up splitting and making these three separate maps to compare our trail accessibility to those various social vulnerability factors.
Yeah, anyway, I don't think we have a question slide, but feel free to ask questions.
I think you could tell us a little bit of a story about how some aspects of this were a little bit more complicated than you thought that you thought they might be.
Yeah, I mean, certainly this is the biggest lift was dealing with kind of all this desperate trail data that, like, shaded in green here, the East Bay Regional Park District, that was kind of the most spatially accurate due to being the smallest kind of unit and being kind of concentrated. But even still, we had a lot of segments that they would be broken at a road, and so they wouldn't cross the road. And so when we're trying to get our 5-mile continuous trail, we had to do a lot of kind of manually, like, bridging and deciding, okay, this does look like the trail crosses here or it doesn't. And then also it's hard to see in my map, but we have, like, the USGS will map places that are inside of a California state park. And so then it's like we need to make a decision there of which source is more accurate, and then how do we get all these things to snap together, was a huge issue. And we had places, where the same trail would be digitized by 2 different entities, and then the geometry would be so wildly off that there really wasn't a great way to do any kind of automated removal of that. We tried doing, like, some buffers, but then that would, even if we did like a 50-foot buffer, you'd have the trails coming way in and out of that buffer that wouldn't be able to remove them.
A lot of long manual labor hours of just going in and manually deleting trails and then placing trailheads and having to mess with how the trailheads are snapping. And thankfully, the package in R did a lot of that kind of snapping for us.
But honestly, the biggest thing to, like, for replication of this, to do this in other areas of the country, which I think would be super interesting, is just finding trailhead data was honestly the hardest part. I mean, the trail data notwithstanding, that is a whole thing as well, but we really did not have a source for trailhead data beyond a little bit from the East Bay Regional Park District, but then it really was not helpful, and we just ended up doing it manually ourselves. But that was a huge task and is totally not complete.
I always tell the students that never underestimate the amount of time that it's going to take to complete a GIS project, for the simple reason that, you download a shapefile or you find something and then invariably you get into it and it's just not what you expect at all. And there's a lot more work that has to be done. I know Lisa will have nothing to say about that when we get to her project.
Get ready.
It's just amazing. Data that you think is going to be there isn't there, or it's basically not in a format that you can use towards your question. So it's kind of a common thing here.
It's a good question. Really interesting project. I'm intrigued by trail access and trails in general, and it prompts me to think about kind of a couple of things. one are data sources, I'm thinking like the Strava heat map, right? And so thinking about, some other sources that maybe you could digitize or to reference, because, the other thing, at least, I don't know if you went into this at all, but I imagine each of these trails has kind of different usage, right? Usage patterns. Some are probably more popular than others. And how does that play into the analysis? Like, maybe people would really like to get to this trail in one part of town, but it's actually really difficult to get to. Just because they can get to one that's closer doesn't mean it's the one they necessarily want to get to. So yeah, a couple thoughts there. The other question I had is about census block groups. Why census block groups and not some other enumeration unit?
Yeah, do you want to answer that about that?
I mean, well, for your first question, yes, we'd love to to do more like that. For the scope of this project, it just wasn't going to happen. But I think that would be really interesting to look at, and actually something that I hadn't thought of yet. Yeah, we were thinking about other expanded things that we can do if we had some more time on that project, and that would definitely be one of them.
Or if there like was I didn't really find a whole lot like on an AllTrails API or something like that. Like that would be great because AllTrails has really great data, but yeah, we didn't have a great interface with that. Yeah, and then the block.
Yeah, block groups. We debated it for a while. Tracks, census tracks seemed to just be like too big for. We wanted to have more granular data, and blocks themselves were going to be just a ton of polygons to work with, and frankly difficult to map. So we decided to have block groups as kind of a happy middle ground between there, where we could still say this is like not a huge input of households in a block group, but we can still pull out some pretty good data. And definitely more granular than you'd get with tracks.
Yeah, and of course we are reliant on centroids as a method, but then that did allow us to pair that back to social vulnerability more easily than if we were to do some other way to just get like I don't know, like hex bins or something like that to grab a bunch of inputs over the city. Yeah.
Yeah, I was thinking the block group would have probably the most social variables kind of accessible. The other one that would be of interest that comes to mind is like, I don't know if San Francisco has like neighborhood designations, right? Like quote unquote, what is a neighborhood? But sometimes you can find that. But again, you may not be able to get social variables at that resolution. Yeah, great work. Interesting.
Thank you.
All right. Anybody else, or pass it along to the next group?
I think we can pass it along to the next group.
Perfect.
Sure. All right, that ought to do it. Yep. All right. So thank you for your time. One of the things that I have learned in my professional and scholarly career is that the legal profession could really, really stand to have better qualitative understanding of data. Infamously, a lot of attorneys do not take a single math class after they finish high school. And so the quality of their spatial data can similarly suffer. And to that end, okay. So nearly all of us experience some kind of civil legal problem at some point. And the real question is, do we end up bothering getting an attorney to help us with it? And for a lot of people, most of the time, the answer is no. It's just too expensive. It's too much trouble. And one of the things that I wanted to do about all of this is to try to find ways of spatially mapping the areas that might be considered legal deserts, where there isn't enough demand going on, because as described, you can see here some of the really disappointing numbers behind the sheer number of people who either don't get any help or don't get as much help as they think that they would need. And the literature mostly talks about the number of attorneys per person, usually on a county level basis. And most attorneys are not dealing with or practicing any area of law that really fits a lot of regular people's needs, such as estates, such as evictions, such as wage theft from their employer, so on and so forth. And so I wanted to try something a little bit different. This is an example of some of the best geospatial data I have found from the entirety of the legal profession, which are some categories of on a county by county basis on whether or not an area was legally underserved based on the number of attorneys per population at the county level, or in the best case scenario, a series of interesting bits of data taken from various sources and overlaid over each other without any kind of crossplay or referencing or multivariate analysis. And because I was crazy and didn't have a proper appreciation for scope creep, I decided to do a multivariate analysis of proximity to courthouses versus overall social vulnerability over the 10 counties that comprise geographic Southern California, which I can show here. So this is 10 counties, 24 million people, approximately $2 trillion of gross domestic product per year, and one of the wealthiest and most diverse and interesting urban mega regions in the world. And so lacking any kind of centralized system on what all the courthouses were, where they all are, and what kind of law they all practice, because not every courthouse hears the same types of matter, I had to create this manually by going into each county's website, finding out the list of courthouses, what areas they cover, and then manually geocoding all of them because the utilities I found were just not fit for purpose. And beyond that, I went into an extremely meticulous and difficult process using census tract data because I found that although the margin of error is really bad, 15 to 20% for any given ACS data for census tracts, it's still significantly tighter than the block group data. So I ended up going with that. Taking a bunch of different factors and processing them all together into these different columns of variable types, socioeconomic data, population structure, race and ethnicity data, access and functional needs, and housing structure, and mushing them all together by comparing weighted percentile rankings so that you could have data per household, data per population, and data per working non-institutionalized population over the age of 25 could actually play somewhat nicely together. The fact that all these data for social vulnerability came from ACS made it more sane to work with, but the real trick was courthouse access. And I opted to try to find the driving distance because transit was just way beyond the scope, but the driving distance that it would take to reach a civil law courthouse within a 15, 30, 45, or 60-minute drive to arrive to that courthouse by 8 a.m. on a weekday when a lot of morning hearings take place. And let's escape from that for a moment. And so using the Calculate Travel Areas feature on ArcGIS Online, which consumes fewer credits than you would think, I was able to find a lot of these data in a very granular capacity. Now, this is simply for all of these courthouses, but I have categorized every single one of these courthouses by all these different types, whether they hear family law, probate law, small claims, etc. I can't layer all these over at the same time. This is merely an illustration of how I was operationalizing these data. You can see here that not all of these census tracts are evenly covered. And so in order to handle that, zooming out too far again, in order to handle that, I used the tabulate intersection feature in ArcGIS Pro, which does have a superior QGIS alternative, I've learned, to just calculate the percentage of overlap of different drive time areas per census tract and assigning a weighted score. If a tract is totally within a 15-minute drive, then it gets a higher score than an area that is only partially within a 60-minute area. Relatively arbitrary, but relatively straightforward, and it allows for this further intermediate data layer, which shows that, even if there's a courthouse over here, it doesn't actually cover that many different types of things. So it's still not very good courthouse accessibility in that region. Just can't get it to zoom that perfect level. So as described before, calculating a weighted multivariate socioeconomic index is, who could have possibly guessed, extraordinarily difficult, with similar variables meaning different things in different places. And I didn't really understand or respect the magnitude of it, but I was crazy enough to follow through anyways. As described before, I pretty much mashed them all together to create something where the weighting itself, I should mention, was based specifically off of too low resolution to see. But every one of these data points are weighted by a different percentage level based off of some literature from consulting various field experts, so that, for example, per capita income is not weighted identically as, for example, household access to cars. Some very wealthy neighborhoods have low car ownership. So this is visualizing where the vulnerability comes in, and that's pretty interesting. But so I married the two together to find the places where the anomalies were. Now, you might not be terribly surprised to see that a lot of the most rural and isolated communities end up having high social vulnerability and very low access to courthouses. But it's the anomalies that are always interesting. And sometimes they show you flaws in your data model, because this little bit in Riverside County right here is not what it looks like. So for clarification, these red areas have high social vulnerability, but they also have very high access to all different types of courthouses. And the blue areas are areas that have very low social vulnerability, but have really terrible access to courthouses. And so what is this community? This is 2 state prisons. My index probably should have factored in the incarcerated population, but that's one of the many ways where multivariate analysis is brutally, awfully difficult. Now, this is normalized per population, because otherwise Camp Pendleton here, which is the most populous census tract in the whole area, would really distort the view of things, because you have a lot of young unmarried men of low income status and often low educational attainment. But in the grand scheme of things, the sheer number of people in there was also breaking the ability to visualize these data adequately. So that's why I weighted it by population. And just as a close-up to some of the county areas, just to have a bit of a look, you can see that these blue areas map pretty well to all of the sprawliest, richest, most car-dependent, bourgeois, post-war, sprawl kind of neighborhoods. But there are some anomalies, and I didn't have the time or the resources to really delve into each. But I was kind of surprised to see that I'm always surprised to see some of these anomalies and would like to dig into them more. Why is this area of the Salton Sea, which is not a great place to live, less disadvantaged than some of the core population centers of Imperial County? Maybe a doctoral dissertation or 12 could be written about that. Orange County has no surprises for people who know the area. It is one of the wealthiest, most suburbanized areas, but there is still a clear socioeconomic divide. This is another, this area here is another confounding variable because this is Seal Beach. This is not, this is a military installation and thus sort of confounding a lot of these factors. And there are also anomalies here in San Bernardino County, possibly the largest county in the whole country. And I believe these are either military installations or natural features. And so yet further complications, multivariate analysis is incredibly brutal. And similar trends going on in the remaining counties. And honestly, Kern County, home of Bakersfield, the least respected city of its size in California, San Luis Obispo County, that is arguably central California, I deliberately included in this because I didn't want this to be an analysis just of greater Los Angeles and San Diego. I didn't have the time or the space to really delve into the specifics, but I suppose I wanted to try to break some ground in legal research. And I guess I could wrap up by sort of recapitulating some of the difficulties that I found. I need to improve the quality of the courthouse data. I need to find a way to include new variables from the American Community Survey that are extremely important here, such as quality of internet and computer access, because a lot of hearings are digital these days, and I have no way of visualizing that using an index that was created in 2005. And beyond that, well, I would end up telling the story of how I spent way too much time on this, and I want to respect other people's time. So I'll open it up to questions. I can't see what's going on here because this is full screen. I can't tell who. I could have sworn I had heard something like that. I don't know how this stuff works. Fair enough. But at the very least, I guess the most important moral of the story that I learned in all of this is that there is a reason that it's extremely difficult and tedious and time-consuming to make these kinds of massive analyses. And if we attain wisdom from our failures and shortcomings, then this project has made me much wiser than I was a few months ago.
That's the whole point of college.
I couldn't agree more. It's very few things than the amount of work that I put into this could have more viscerally taught me the importance of like grounded specific project management styles and data science in general and other types of weighting methods.
From my perspective, it seemed like your project was enormous. At any point, did you
Yes.
consider downsizing to be smaller?
I had considered it, but ultimately deemed it to be boring. And so I ended up biting off not more than I could chew, more than I could carry. And so that's part of the lessons learned. I could easily have done a dissertation level project on this subject matter on Los Angeles County alone. And now I understand why.
Might you do that in the future?
If I persuade myself to apply for a PhD program, perhaps. It's not literally impossible.
Nothing's impossible.
What do you think are the one or two things that you traded off from by taking a breadth over depth approach, right? Like you took a really broad, far-reaching approach, and you highlighted some in your presentation, right? Some things that you weren't able to dig into, but assume you had reversed it and maybe, took a deeper approach, maybe into a smaller area or using less variables, et cetera. Like, what do you think was the biggest trade-off? What would you have liked to have dived into the most?
Precision of court data, first and foremost, because Well, for one, Los Angeles County, I broke all of the drive areas to clip by county area because if you have a legal problem at an address in a given county, even if a nearby county's courthouse is closer, you are in your county's jurisdiction. And just clipping by county worked fine for every county except Los Angeles, which has such scale and scope that they actually have their own internal jurisdiction system, which I didn't have the time or the resources to really break down each particular type to do it proper justice. And I wasn't able to, in my data, visualize that, for example, every single community that needs probate court hearings in Los Angeles County has to go to downtown, except for the northeastern corner, which has a probate courthouse that applies only for that one district. So I would have more accurate court data. I would have the ability to maybe make some more tight generalizations from just one county, and I'd be able to literally more accurately map the data. Again, I realized, sort of grasped the folly of my scope creep and scale. Yeah, I think that'll do it.
Wait, don't do it. What's that? Put that there.
Okay. Again.
There, now we can read that.
Okay.
Okay, so we did our project.
My name's Maya.
Oh, hang on. I'm Peter, and we did our project on analyzing the correlation between well-lit streets and crime in Madison, Wisconsin. It's kind of what it says there. For our 578 capstone project, we decided to interrogate our assumptions that streets are safer when they are comparatively more illuminated because they feel safer. We mapped the location of streetlights in Madison, Wisconsin, where we have personally experienced being a pedestrian the most often.
So to compare the density of lighting on streets and paths, we map the average number of crime reports occurring on each individual streets to identify the streets with high crime rates. To assess the strength and direction of the association between light density and crime rates, we ran a Spearman correlation in R and found a statistically significant but very, very minor positive correlation between the two variables.
We compared how light density is related to crimes occurring at night to overall crimes as a control variable to better isolate the impacts of illumination. Positive correlation was somehow higher at night than overall.
This challenged our previous hypothesis that less crime would be found on well-lit streets. We also used R to run a linear regression model to assess the potential causality of the two variables and essentially found that the street light density itself is not a significant predictor of crime, but the correlation is still revealing of a pattern that might be better explained by high foot traffic, preventative street light placement, and/or crime reporting being easier in the light.
Our main output map colors street segments according to their crime rates. Lighter colors have higher crime rates, darker colors have lower crime rates. This overlays the street light point data.
And as you can see, there's high crime rates concentrated around the Capitol and State Street, which also have high concentration of streetlights. This is a zoomed in part of the more interesting part of our map.
The implementation of
blueprint was relatively straightforward, but we ran into road bumps in getting specific tools to do what we wanted them to do. One of our biggest challenges from the project was trying to manipulate the data through joins and spatial joins to get accurate counts.
We struggled to keep unique object IDs straight so that they would always refer to the same thing. And we would get super excited when it looked like a join worked because finally there would be like numbers in the count field. But we would go to verify and manually count the lights for each street segment, and it wouldn't always be true because the object IDs weren't referring to the same thing.
We also struggled to get the ideal selection of crime data from the Madison Police Department because they get a lot of requests, and we pivoted from a temporal 2025 approach to a comprehensive year of 2024 approach. And they still haven't gotten back to us on that new request.
So it's been a while. It's been at least 2 weeks, So while it was less than ideal, we worked with the crime data from March 2025 and September 2025 and sort of treated them as generalizations of a total crime pattern for 2025 because they still, for the most part, capture an average level of foot traffic that's independent of seasonal spikes from like summer or winter when there's less people or more people on the streets.
We would still prefer a full year and look forward to getting that data and adjusting our project analysis to the larger crime data set. Then we'll be able to include campus crime since we do have the campus 2024 data from UWPD. So that would better give us overall picture, overall Madison, because right now we don't have campus for our 2025 data that we actually ended up using.
And we also had like some major trouble like merging the streetlight data because we used 3 different sources so we could get like a bigger scope. We have 2 from the city that are like open source, and we had 1 from campus. Okay. We had 3 data sources for our lights, and we tried to merge them all together, and they just were not behaving the way that we wanted them to. And so we went to the one person that we knew could help, our boss at Campus Mapping, Paige Taft, and basically she solved the problem by setting the merge rule to some, and that's all it really took. But once we figured that out, it was smooth sailing. Yeah. So this is our correlation scatter plot. As you can see, it's extremely skewed, which is why we chose the Spearman correlation model because it's supposed to be better for skewed data because it's rank based. Yeah, and so we did it based on streetlight density and night crime, and we held a sort of constant variable. What's the word? Control variable as like total crime rate just to see if the lighting itself had any like impact on it. But as you can see, the density plots are basically the same, slightly positive, very slightly positive, and then it actually like the effect is stronger with night crime, which is counterintuitive to what we originally thought. Yeah, so that's our map. Should we go back to the map slide? Beautiful map.
Should have put the like actual numbers in there too.
I'm sorry.
Good.
You just have to trust me. Yeah,
Okay,
so this is our lights, and then
if we also go back to the lights, you can see some of our
Use the arrow.
oh yeah.
See, even though we did have 3 separate data sources, we still are like missing lights in some areas. Like this whole
kind of
area here doesn't have lights for whatever reason. And then like parking lots were also a big one, like both West Town and East Town Mall. We had crimes there, but we didn't really have light data there.
Yeah, because it's hard to like account for private owned like streetlights and stuff, just because it's not going to be included with the city maintained ones, and those are all publicly available. And you can't go to every single mall and be like, "Can we have your crime data?" or "Can we have your light data?" Because they don't have that. Yeah. So then there's that beauty. Yeah. Any questions? Any questions? Should we stop sharing? You have a question? What?
Keep it shared if they want to ask us.
Yeah, Sorry. Reed has a question. What's the question, Reed? Oh, yeah.
So, what do you think? Oh, I'm sorry, I hear my own voice echoing.
Okay, there you go. Maybe just go up and ask him.
Why do you think?
We got it. Guest appearance. You can come on screen.
All right, so why do you think that you ended up getting sort of the opposite results that you expected from light and crime rates?
So we think it's probably one of three things, or maybe a combination of the three. So it could be that the data that we use for crimes is based on crime reports and incident reports. So those may be more likely to be reported because they're seen because of light. It could also be because maybe the city noticed that there's certain places, maybe a state street, where there are a lot of crimes, and they put more lights there to help deter the crime. So maybe there is an effect there that we're not seeing because this is sort of a preventative thing. And then there was one other, what was it? I remember.
Trying to remember, I lost my train.
And then it could also because there's just more foot traffic in these areas. So there's more people and there's more of everything else. So there's going to be more crime if there's more people walking around on the streets in these specific areas. Hello? Yeah, hope that answered your question. All right, yeah, that's it. We can pass it along to the next person.
Okay, we'll call that good.
Slay.
Yeah, I gotta share my screen. Where is that? What's gonna happen? I share. This is scary. I have so many tabs open. Do it here. Share that one. But now it's on the wrong slide. Stop share. This is embarrassing. Okay, how will we do? Sorry. I promise you I use Zoom all the time. Okay, so now I need to share this screen because it's on that screen. Then now if I share this, there we go. Now you can see it, right? I do.
We can't see it, no.
No. Sorry. You can see my background, and now you can. Now you can see it?
Yep, now we can see it.
Okay, thank you. All right, thanks for bearing with the grandma using the internet. So for my capstone project for the master's program, I made a educator-focused geologic map of the Ice Age Trail. For those of you that don't know, there is this giant trail system in Wisconsin. It's about over 1,000 miles long, and it's not continuous. It has developed sections and then some undeveloped sections. But the Ice Age Trail partners with local schools along the trail system to get fourth graders out on the trail, and that's called the Saunters program. And my purpose for this map was to bring the geology along the trail to life. In my real life, I am a geology professor, and so I get asked to do a lot of these things with local chapters and local schools a lot. And So I thought, well, maybe I can start to bring some of these resources to the teachers that are tasked with taking the students out on the trail and the Ice Age Trail volunteers, so that they don't always have to rely on me, and I can share some of my knowledge and make it more accessible. So to do that, I have a daughter in fourth grade, and with teachers that take their students out on the trail. So first step, I met with them to be like, hey, I have this crazy idea for this master's program I'm secretly in. I didn't tell anyone. I haven't really been open about that I'm doing a whole nother graduate degree on the side. And so I met with them and was like, hey, what do you need? Because I know what I need to teach college. What do you need to teach fourth grade? And so I got some ideas from them. And basically they were like, okay, well, I need to know what trail system, like what trail segments are nearby, how to get to them, what type of geology is along that trail, and what are some activities I could do to bring that geology to life. And so after that discussion, I came up with these 3 different tabs, which is kind of like the meat and potatoes of my app. And so when a teacher clicks a trail segment, these 3 tabs are populated with information specific to that segment. Each segment varies in length from a mile to like 20 miles long. So each part is covering a different length of the trail. So that was kind of the number one thing. So I had to keep in mind that I'm making this for the teachers. So that brings me into the data, which Bill mentioned. So I used both bedrock data, which is like the hard rock that makes up the crust of the earth, and then the glacial data, which is the dirt and rocks kind of sitting on top of the earth that are scraped up by the glaciers. So I have 2 different layers. And thankfully in April of this year, the glacial geology was published and updated, and it's beautiful. Oh my gosh, the data set is just amazing. And so that was easy. And then when it came to the bedrock geology, I was like, oh, of course there's going to be a bedrock map data set of Wisconsin. And this is what Bill was mentioning earlier. There is not this. So this, what we're looking at on the screen, is the geologic map for the bedrock of Wisconsin. And I was like, oh, this will be digitized and maintained by the state, and it is not. So to come up with the data for my app, and I only focused on 4 counties for my project because I just knew the amount of time I was going to have to dedicate to this project, and I was like, I can't do the whole trail system well. And I live in Marathon County, and so all of these places were within driving distance, and the geology is really interesting because there was a different ice lobe in each of these different counties for the most part. So it's different geologically, and it's close to me, and it's smaller scale, so I could handle it. So to get so this on the left, this is the beautiful superficial geology. So that's the dirt and rocks sitting on top of the earth. And then here's the bedrock. So I had to create my own data set, doing some digitizing based on some of the counties that didn't have any data. So I was pretty surprised by the lack of data. So much so that I decided to write a good old grant to my university, UW-Stevens Point, to see if I could get some funding to task a undergrad major, cartography major, GIS major to help me with that, filling that hole. So then after I have my data, which includes these 2 layers as well as the trail itself, which is an orange, and then points of interest along the trail that I gained from reading a book called The Geology of the Ice Age National Scenic Trail, which it goes into incredible depth about the different features found along the trail. But I wanted to make that information more digestible. So I took the information that I could find and tried to rewrite it so that somebody who doesn't have a geology background could understand it. And I was communicating with the fourth grade teachers periodically because I'm the PTO president and I bring them lots of food. And so I would also be like, hey, can you read over these? And does this make sense? And so maybe the Qdoba helped. But they are always like, this is great. So that was helpful. And then the part that I spent the most time on, which is not going to be surprising to anybody who's made a interactive geologic map or any sort of interactive map, is just iteration. Broke my app so many times, and then I have to figure out how to fix it, and then I'd have to be like, okay, well, I don't really like the layout of this. I'm going to change it, and then I would just like it just be constantly updating, fixing, seeing what I like better. And that took up like 80% of my time once I had all the data. So just going, and this process could honestly still be going, but there was a due date. And so I just had to deploy, right? It had to be good enough. And so the things that I learned from this project is to keep the user that you're developing an app for in the forefront. And so for me, that was my fourth grade teachers. I had to, okay, how do I want this user interface to look like so that a fourth grade teacher who's never seen this before would know how to find all of the information I'm providing on this app. The other thing I learned is that it's hard, it's difficult and challenging to take complex geologic concepts, like an ice-walled lake plain, and simplify it so that a fourth grader, which is somebody who's 9 to 10 years old, to be able to understand. And then the biggest lesson I learned is that, like, please save lots of time for making things work, and getting the app to be the way how you want it to be. And I also learned that this app and GIS in general is a form of communication. I have a lot of knowledge that I was able to put into this app and then share with the larger world. And so far, I actually was able to present my app at our local chapter meeting last night for the Ice Age Trail, the Marathon County chapter. And man, they were so excited and enthusiastic about it. I'm sure the 12-pack of beers I brought wasn't any sort of help in that, but so far it's been positive in the real world, not just in my classroom. So it's so far so good. I'm excited I get to present this in April at the Ice Age Trail Alliance conference to more Ice Age Trail users. So I get to communicate lots of things. So with that, I will take your questions.
Did any of the teachers you showed have a lot of feedback, and how did you integrate that into what you did?
The teachers I was able to talk to were they were humoring me, and what they told me is when I presented there was some of my activities, because I came up with activities for each of the trail segments. Some of the activities repeated, but I was like, here's what I'm thinking. You can like make a glacier and then have it go. And they're like, okay, but yeah, we would need step-by-step instructions. And most importantly, for them to do anything, they have to have it meet DPEI standards. So like what learning outcomes in the science curriculum will this activity meet? So that was something that was totally new to me. And so I was like, can I have a list of them? And so they provided that to me.
All right, I'm gonna ask a question, Lisa. Sorry, dealing with technical issues. Okay, there we go. Still okay. I'll just use the computer. Okay, there we go. All right, so I'm just curious about, you mentioned using, well, first of all, if this is public, we would love to be able to see it. I don't know if you have a link out to it somewhere.
It's so scary to share it, but yeah.
Okay, but then other than that, though, I'm curious about, you mentioned doing like custom ArcGIS stuff. So is that like the ArcGIS API for like the Esri ArcGIS API, or is
Yep.
that Experience Builder for Depth? Okay. And so what was your decision there to go that route instead of MapLibre?
It's just
or
what I
Leaflet or-
understood.
Oh, okay. Cool.
My whole approach was was to keep it simple and get this degree across the finish line. When I saw Reed's diagram with all of the arrows and I was like, oh my word! When I had to make my own for this, it was like literally 4. And I was like, oh no.
Yeah,
So
well,
it
and you
does
already
seem
had
like you guys have a lot more fun in the in-person classes.
you already had so much with all your data work that then to do all the interactive stuff too, it's a lot. So
Yep.
okay, thank you.
Mhm. Bill, are you going to give closing remarks? Or did he leave?
Yeah, I'm not sure. He must have gotten kicked off the call somehow. I'll just say thank you, everybody, for presenting. It was really awesome to see all these different projects and all the different angles you took and the different amounts of scope you were able to handle or not handle. So thank you, everybody. This was great. Right. Goodbye.